So we have a diverging lens with a focal length of negative 20 centimeters. So diverging lens, focal length of negative 20 centimeters, is placed 12 centimeters to the left of a converging lens. It's focal length of 35 centimeters. 2 meter tall object is 50 centimeters to the left of our diverging lens. We want to find where the final image is located and how tall the image is. So we know the focal length for lens 1, the lens the light will pass through first. We know S1 is 50 centimeters. So S1 prime, we know that 1 over S prime is equal to 1 over F minus 1 over S. What did you get for S1 prime?
Negative 14.285.
Do we concur?
Wolfram Alpha says so too.
I'm going to go ahead and round 14.3. Negative means the image is showing up on the same side as the original object. So this image, obviously not drawn to scale, .3 centimeters in front of that lens. Now its orientation, magnification. Magnification is negative S prime over S. So negative 14.3 over 50. So we get a positive. Did you get that? What did you get?
You know what? Magnification for the first one?
Yeah.
0.286.
Do we agree? Fabulous.
With magnification, do you want to put the positive sign in there?
Doesn't matter.
Okay. Just wanted to mention it.
I'm just trying to remind you that the positive sign has a specific meaning. So we know then that the image is upright, is the positive sign. And it's a lot smaller, 0.286. The image will be a lot smaller than the original object. So that image becomes the object for the second lens. S2.
12 plus 14.
Exactly. S2 is the distance from our second lens to that image. So 12 plus 14.3, so 26.3 centimeters. So 1 over S prime, 1 over F, which is 35 centimeters, minus 1 over S, which is 26.3 centimeters. What did you get for S prime?
Negative 105.6 centimeters.
Wait, what? Sorry.
0.6.
Do we agree? Okay. Negative sign. Now we know the image is going to be 105 centimeters from this second lens. Which side? Left or right?
Left side.
All the way out there.
All the way out there, 105 centimeters. I can't, we'll be out of camera range, so I'm not going to bother drawing it. So negative sign means it's on the left side of this lens. It's 105 centimeters away. So that's the image. So we could say 105.6 centimeters to the left of the second lens. That answers the first part of the question, where the final image is. Magnification. We need to know the magnification of the second lens as well. So negative S prime is negative 105.6 centimeters. over S, which was 26.3 centimeters, which is positive.
4.02.
So magnification total is going to be just the multiplication of these two magnifications, so 0.286 times 4.02. Total magnification is positive,
1.15.
close to 1 again. Okay, that's not the question we were asked to answer though, but it's important. We want to know how tall the image is. We want to know the height of the image. How do we find the height of the image?
Multiply the height by the total.
Right. Total magnification value times the height of the object. So absolute value of the magnification times the height of the object, which is 2.3? So the image is 2.3 meters tall. Yeah.
So assuming we have a negative S prime, can we pass it back through the diverging lines?
No. Well,
It's not a real image, is it?
it's not a real image. S prime is negative. It will be virtual. There will be a little bit of reflection that could pass back through the diverging lens, yes. But having a negative S prime doesn't mean all of the light went back through the diverging lens. All of the light comes through both lenses. We're over here looking through them. We just see the image as if it were 105.6 centimeters back there. It's not because the light went back there. Does that make sense?
Yeah.
But there is some reflection just by the nature of waves. Whenever they hit a surface, some of them will reflect. So there would be a little bit of light that goes back through. I don't know if it would be intense enough to form a really good image or not.
So, is the fact that it's farther back, but slightly taller, cancel it all out? So it looks almost the same,
It looks just about the same, only further away.
but slightly bigger.
So to us, depth perception-wise, it would look smaller.
Okay.
The actual.
But the actual image is bigger.
Right.
So with that, yeah. whatever.
So something 2 meters tall here, and just over 2 meters tall here, from far away, just due to depth perception. This may look a little smaller, just because of depth perception. It may not be far enough for it to be significant, so they'd probably look pretty close to the same size. One just a little further away than the other.
For a way to relate distance and height.
Magnification-wise, in terms of magnification being S prime over S,
But like, so for you standing, whatever on this side, if you were looking at the first one that appeared 2 meters tall, how much would this one appear to be in accordance with this?
you could do it in terms of angles.
Well, like say you've got two people that are 6 feet tall each,
Yes.
and you have no depth perception. You can't tell that they have a certain distance apart from them. One man stands 3 meters away, the next man stands 5 meters away.
The other one would look shorter.
The other one would look shorter.
Right.
So what I'm saying is with this, cancel it out. So say you have one man slightly taller who's slightly farther away, and one man who's slightly shorter, closer, but they look about
They
the
could
same.
look about the same height, yes.
Oh.
Certainly.